So we're going to do a double integral today, and I'm going old school with the tablet. It's the integral from 0 to 1 of the integral from y to the square root of 2 minus y squared of cosine of x squared plus y squared dx dy. So let's start by writing out what the region is. Because as you can see from the title of this video, we're going to be using polar coordinates. So our region is the set of all points x and y, such that 0 is less than or equal to y, which is less than or equal to 1, and y is less than or equal to x, which is less than or equal to, well, the upper bound, which is the square root of 2 minus y squared. Okay, and this looks like nonsense right now. It's easier if we sketch this region in the xy plane. Okay, so let's work with the bounds for x. Its left bound is the line y equals x. And the right bound for x is the curve x equals the square root of 2 minus y squared, which is part of a circle. So we have the left bound is a line, the right bound is this part of a circle. And we're going to switch this into polar coordinates. So we need to figure out what is this angle here. And that angle is 45 degrees, which is pi over 4. We could do a little trigonometry to figure it out, but it's pretty obvious just from our knowledge of trigonometry. So our region we could rewrite in polar coordinates as the set of points r and theta, such that theta goes between 0 and pi over 4. And what about r? The smallest r could be is also 0. And the largest r could be is square root of 2. That comes from the right bound. Right? That circle is a circle with radius square root of 2. Okay, and so before we switch the polar coordinates, we have to switch our function from x's and y's to r's and thetas. And we know that x squared plus y squared is equal to r squared in polar coordinates. So our function is cosine of r squared. And dx dy, that's equal to r d theta dr. It's also equal to r dr d theta if depending on which way we choose to integrate. So our integral is the integral from 0 to root 2, integral from 0 to pi over 4 of, now what's our function? It's cosine of r squared r d theta dr. Okay, and there's no thetas in our inside function, right? Our inside function is just a constant with respect to theta, so it's really easy to integrate. So now we have a single integral. We have that pi over 4 on the outside coming from the bounds from theta of cosine of r squared times r dr. And we're going to do u substitution with u equals r squared. You're all adults, so you could do it on your own. But du would be 2r. Actually, most of you aren't adults, but you could still do it on your own. Okay. So we have, when we do this integral, we have pi over 8 sine of r squared evaluated at our endpoints. And so now just finishing it up, plugging in our endpoints, we have pi over 8 times sine of, when you plug in root 2, you get 2 minus sine of 0. Well, sine of 0 is just 0. So our final answer is sine of 2 times pi over 8. And that's it. So let me know in the comments if you like these types of videos. Thanks for watching.